Alright, today we're going to continue looking at factoring quadratics, but using the perfect square trinomial as well as the difference of two squares. So if we take a look at this one, this is our perfect square trinomial because we have three terms, and our first term and our last term are both perfect squares. So I know I have two pluses, so my end factoring needs to end up looking something like this, and it's going to be a plus. So I know 4 is really 2 squared, and 9 is really 3 squared. So when I factor, my a is the 2, so I have 2x, and my c is my 3. So 2x plus 3 squared. So let's take a look at this one. It's a perfect square trinomial because we have three terms, and our first and our last terms are perfect squares. But since one's negative, we're going to be using this factor form. So we're going to end up with a negative. So 64 is really 8 squared, and 1 is 1 squared. So my a is 8, and my c is 1. This one's also a perfect square trinomial. We have three terms. First and last terms are perfect squares. They are both positives. So I know 25 is really 5 squared, and 81 is 9 squared. So my a is 5, and my c is 9. Looking at these bottom two, we're working with the difference of two squares, so that's where we have two of our factors. One is positive, one is negative. So I know I'm going to end up with positive and a negative. So I have a 1 squared and an 8 squared, so my a is 1x, and my c is 8. So that's our factor for the difference of two squares. So let's look at this difference of two squares. Remember, one positive and one negative. 4 is really 2 squared. 49 is 7 squared. So my a is 2, my c is 7. And that's how we factor the difference of two squares.